Good morning, CP Pre-Calc. What we're doing today is we're going to continue to investigate oblique triangles. Now, let's remember an oblique triangle is a triangle that does not contain a right angle. So we're talking about acute triangles and obtuse triangles. Now, what we're going to do when we investigate our oblique triangles today is we are going to look at a way to calculate the area of these oblique triangles. Now, in geometry and probably prior to geometry in middle school, when you were asked to calculate the area of a triangle, you use the formula 1/2 base times height. So your area of your triangle would equal 1/2 base times height. But what we're going to talk about today is, in this case, what if I don't have the height? So you're used to having the height of triangle. Remember, the height of a triangle is from a segment from a vertex down that is perpendicular to the opposite side. But if you're given two sides and an included angle, we won't need to know the height in order to find that area. We can use the formulas that we have here. So this is like special fun with area. Now, if we take a look at this special fun with area, these are the three formulas we can use to calculate the area of an oblique triangle. Now, when you look at this is SAS, meaning you're given two sides and an included angle. You can find the area by half the product of the sides multiplied by the sine of the angle. So in this case, the reason we have three formulas, because it will be based on what angle you're given and what side you're given. So if you'll notice that you have an angle, the side that you won't have is the side opposite that angle. So for example, if I'm given angle A and I have B and C, I would use the first formula in this case, which is A equals 1/2 BC times sine of A. If I'm given angle C, and I have side lines AB, I would use the third formula. Area equals 1/2 AB times the sine of C. Now remember, guys, when we calculate this, we're doing everything in degrees, so make sure your calculator is in degrees. So now in this case, they say find the area of triangle ABC if A is 10, B is 14, and C is 46. So if you take a look at this, we know it's the included angle, because if I highlighted it here, actually let me not do blue because it's blue and purple, I can look, I'm given A, side length A, I'm given side length B, and I'm given angle C. So you'll see that C is included between A and B. So if I'm given angle C, I am going to use that third formula, if it lets me highlight it right there, guys. All right, so I'm going to use that third formula. That's the formula I'm going to use. So if I come over here, I'm going to say the area will be equivalent to 1/2. It says A times B. Well, I'm given A is 10. I'm given B is 14, and I'm giving the angle C is 46 degrees. And all I'm going to do, guys, is input that into my calculator. 1/2 times 10 times 14 and sine of 46. And if you input that into your calculator, you're going to get the area to be 50.354. And again, since we're talking about area, this needs to be units squared. So if you're not given an actual unit, you want to put it in unit squares. So that would be 15.354 unit squares. That would be the area of the oblique triangle ABC. Now we can use that again when we're given side, angle, side. All right, guys, when I'm given side, angle, side, I just want that highlighted. I don't know why it's there. We're good. Side, angle, side. All right, now there are cases also. That's one case where we can find the area in an oblique triangle. Now, another case could be when we have side, side, side. All right, guys, we can also find the area of a triangle when we have side, side, side. When you have side, 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 you can find the area of a triangle by using Heron's formula. So that's the name of the formula that we have here. Now, Heron's formula, the area of the triangle with lengths A, B, and C is equivalent to the square root of S, which is going to be what we call our semi-perimeter is S. Okay, guys, that semi-perimeter is S. So S, I don't know why okay. S times the quantity S minus A times the quantity S minus B times the quantity of S minus C all are under the radical. All right, guys? So if we take a look at this, find the area of the triangle of A, B, and C. Now, if we take a look, just so you know, that's a little c. So that's not supposed to be a big C. This is supposed to be a little c. You're given three sidelines. First, you want to find what we call the semi-perimeter. Now, the semi-perimeter is exactly what it means. Semi means half, so we're actually finding half the perimeter. If you're given three sidelines, all you have to do is to find the perimeter of the triangles, add those three sidelines up, and then take half of it. So your semi-perimeter in this case, let me do that with the red. My semi-perimeter would be 1/2, and my three sidelines. 8 plus 11 plus 5. So that would be my semi-perimeter. So when you take a look at that, you want to make sure that you calculate that semi-perimeter and you're going to use it. And in this case, my semi-perimeter will be 12. Now I'm going to use that semi-perimeter in my area formula. So I'm going to have my area is equivalent to the square root of the semi-perimeter times the semi-perimeter minus A, which is 8, times the semi-perimeter minus 11, which is B, times the semi-perimeter minus 5, which is C. So we're going to input that in. So you're taking the square root of that whole quantity. So if you want to first multiply it, which is fine, if I multiplied under the radical, all right, guys, I'm multiplying everything under the radical. You can put the expression under the radical, including all the parentheses you see, and you would get to this to be the square root of 336. Now, if I want to find the square root of 336, that is approximately 18.330. Now, again, it's area, so it's going to be units squared. And that would be my solution. And again, we can only use this area form, Heron's formula, if we're given SSS. So the only two cases where we're going to utilize area formulas is if we have SAS, we're going to use our formulas up here, the three choices. And if we are given SSS, we are going to use Heron's formula. All right, guys? So that's what we're going to have to work with. Those are the only cases in which we will be calculating the area of a figure. I know, in this case, an oblique triangle. All right, so part of your homework, guys, just so you know, part of your homework is going to be on this last page here. You are going to have to do C and D, find the area of these two triangles. That's part of your homework, and the only reason I say that's part is because there's one more thing I want to go over with you today.